Okay. In today's class, we're going to spend the first half an hour for lecture and then the last 15-20 minutes for quiz one. Are you ready for quiz one? It's open book, so you can do whatever you want, but just not communicating with your classmates. That's it. You can use ChatGPT if you want to. It should be simple and straightforward. I was supposed to do lab 3. It's on Canvas. So all the quizzes you're going to have, it's kind of similar to lab assignment. I provide the notebook on Canvas. So go there, you find the link, and then just click. After finish, submit the link to your GitHub collab URL and also a screenshot of the maps, and that's it. So each quiz, this one quiz one only has one questions. So hopefully it doesn't take you too long. We're today I'm gonna go through some of the things that you might need that for the quiz and also for lab assignment. Any questions? No? And so for all the quizzes, if you're not here, you will get 0 unless you have a valid excuse documentation showing me that you cannot be here. And if you can show me documentation, I will give you the average score of quiz 1 for the whole class. Okay, you cannot retake it because I post the answer key as this. You will get 100%. So just that you know, you can. It's okay to miss. But if there's no valid documentation, you will get 0. And it doesn't hurt you too much, but if you miss too many, then it becomes a problem. So today we're gonna cover feature collection. In the previous lecture, we have covered image collection, right? How you do the filtering, how you select the data. Essentially, for this chapter, after this, you need to be very clear about where can you get the data, how do I filter the data for specific area, for specific time period, and how do you do quickly visualize the data. So if you have that, now basically you can watch any movie you like, streaming any geospatial data you like. One of the things that you need to use is to use some vector data to narrow down the imagery to the area of your interest. Okay, so we have talked about geometry and then using a map to create a rectangle, create a point, and then do the filtering. But today we want to more formally introduce feature collection, the vector data. So you can think about a feature collection is GeoJSON or file. Like traditionally, you have rows representing geometry and also attribute. So here, let me quickly run this one. Okay. In the in Google Engine, so there are a couple vector, some like commonly used vector data. So this one is including the so-called Tiger. Again, this is the unique ID. For instance, you can think about this is like national scale raw data set. And if you're interested in doing transportation, for example, this might be a data set you want to use. And so this one, without cloud computing, you need to download a huge data set. So this one is many, many gigabytes. But now you can streaming, you can just view the data where you any way you like, and you can see the raw network pretty nice over there on top of the Google Map. It's not 100% the same because this one is not. You see the date from 2016, so it has not been updated every year. Google Maps certainly has more here. For example, if you over there on top, but for the major raw network, it should be pretty much the same. Of course, there are some building and other types of information in here. So for all the vector data, it's using e.feature collection. So this is, again, it's a server-side object. It will be e.image, e.image collection, e.geometry, e.feature, e.feature collection. Most of the time, you don't need to use e.feature explicitly. Usually, it will be geometry and then feature collection. Because a feature is basically just one row in the attribute table. So most of the time you're dealing with a whole bunch of vectors. So I think you need to master these 4: image collection, feature, geometry, feature collection. And with that, you can do all kind of analysis. So this is the vector data. We are basically pointing to the census node network. And then you can specify you want to set a center. So this one here, the map.set center. So it's kind of similar. You can, when you create a map, you can specify the center and the zoom level. or you can create a map first, like global map, and then add the data layer, and then you zoom to the location. So it's up to you. It's the same procedure. Create a map, zoom to the location first, and then add the data layer, or create an empty map, global map, and then add the data layer, and then zoom to there. So the same. And this is the step that you actually load the data. And for most of the vector data, if you don't, vector data, the visualization is not very convenient. Usually, if you don't know how to visualize, just put a square curly brackets, and then it will look like this. So in that way, you don't have to worry too much about how you actually visualize it. So here, if you zoom to any location, if you zoom out or zoom in, you see this kind of a take some time because of the bandwidth is going to stream the data. So if you want to query the data, you can use the inspector, and then I can hover my mouse somewhere here, close. Hopefully, it should be able to query. Take a look. I think maybe it might be a bug. Polygon usually works, but line sometimes you need to be very close. I think there's just a threshold. I need to look into the source code. I will show you the polygon later. So what we want is when you load the data, you want to see the attribute table. Let me see if I have an example here. Yeah, this one. Take a look at this one. So the US state, for example. So this is the US state, all the polygon. And so this one shows you how to do the filtering. Let me create one here, like might be easier to understand. So I'm going to create a map, and then just add. Let me remove this one, so I don't need Texas. Let's say I want the map for the entire US. So you are having this variable pointing to the feature collection of the entire US, and then you can center the location. So here I can change it. Make sense? So we create a map, and I want to see the US state boundary. I add the data layer of this US state, and then there's a function called center object. So this one is nice because sometimes you don't know the coordinates, the center of your object. So you can just center this object, you automatically calculate the center. So in that way, I don't need to remember the latitude and longitude, right? If I'm doing here, you know US, you can just 40 and then negative 100, but it would be nice that you don't need to make it special. Okay, this doesn't look good because it includes Hawaii and other stuff. So the center is probably in here. It doesn't look good. So in that way, if you want, you can like specify one. But this is the most basic way that you can add the vector data. It doesn't look good is because it's just half transparent, fill the color into the boundary. But the nice thing is this is where you can inspect the features. So after load the data layer, and then you can click this one. I just select it. Right. So now you can see the feature that you selected. So the properties, and then the name of the property. So think about the property is, if you ever use a swap file, open in GIS, you open the attribute table, and then you're going to have the column name and then the associated value we selected. So this one here is basically showing you the name, the column name, and the associated value associated with that column. So this is Google Engine doesn't really have the interface, so you have to do this kind of selection to be able to show the attribute table. There's no interact GUI that can open the attribute table that can see all at once. Gmail have some of those, but this is the most basic way that you can query. So this is for the entire US. So think about here for the entire US. And when you click your mouse somewhere, it's going to be able to query. So get your coordinates, get the coordinates of your map, mouse click location, and then send that to Google Engine to do the computation to do the selection. So the one I just selected here, for example, is Utah. Right. And click another one. If you're doing vector data, you want to check this box so that it's expand automatically, so you don't need to click the box every time. So if I click here, now I see automatically expanded. Right. So check the box. Is otherwise you need to click that every time because it's collapsed. Right. So it saves space, but it's not as convenient. So what you want is to figure out what kind of attribute table in the map. So here, look at the state name. So if I click Texas, click this one here. Click Texas, and then if you scroll down here, which attribute indicate Texas? Name and STUSPS. Okay, state name, the USPS state name. Of course, there's also this one, but number is usually difficult to remember. So you can either like, okay, TX or Texas, right? So these two columns. And this is where you actually do the filtering. So you need to very clear about how you actually filter the data. So you just like what we talked about previously, I give you a tons of images. You know how to filter by date, by area, and also by cloud cover, for example. Vector data is similar. How to actually filter the data to get what I want, right? So right now I'm giving you the entire US. You have tons of data. I just want Texas. How do I do that? Right. So what you need to do basically is based on this one, you need to do the filtering. So Google Assistant is kind of very much similar to image collection. The filtering is using a filter function. So what we can do here is to have a space and then go to the next line and then dot. Okay. I think you need to, let me show you here, probably more intuitive. So you can put at the end and then dot, press tab. It's going to show up the list. And this is going to be filter. So the filter means the filter function here, right? You can filter bounds. You can certainly filter bounds, just like what we did in the previous image collection. You can filter bounds. So let me quickly show you, right? If you want to use filter bounds, I can do this. No, but you cannot do it at the same time because when you read one, it will recreate a map. So let's run this one again just to show you how you filter image collection by geometry. So here, right, I can simply zoom to a location you want. Do the same thing. You can just create a point or you can draw a rectangle, right? Okay, here with that, now I can do the filtering. So let me create a new one. So previously the image collection is state dot filter, right? Filter bounds. How do I get the rectangle? Method RI, user RI, and then run this one. It should not take this. Okay, it's done. It's a little bit slow, but now take a look. Tiger US feature. There's one feature being selected. Is it Texas? So this is how you can do the selection interactively. It doesn't have to be one feature. You can select multiple. So let's say your study area is the southeastern United States. I can just simply draw a rectangle here. Oops. And your source code should remain the same. You don't need to change it. Now, usually after you do the selection, you want to maybe save to available and you can add the data back to the map. So I can do maybe, for example, southeast United States equal to what I selected and then run this one. Oops. And you might notice when I assign this one to something else, it's very fast, much faster than when I earlier we down this. The reason I mentioned this is when you assign to something, you are actually not displaying it. You are not seeing the attribute table. So the code is not being executed. All right, so I can show you again, right? Run this one. You see, like seconds, because you're not requesting the data. But right now, if I type this variable or I directly run this one without assigning to variable, you're actually requesting the data to see what's inside. It's going to take some time. So if I run this one, see, you have a star, it's stuck there. It's actually go to send to Google Sending. So you need to understand how actually Google Sending works. When it's actually executing the code, when it's just giving a placeholder, just not doing anything. It's a bit too slow today, but usually it should be pretty quick because this is not a complicated operation. What it's doing in here is to just say, is it frozen? Yeah, my computer frozen. So it's selecting all the polygons intersecting with the area that I just selected. Okay, it's done. Now if I scroll down, you see 10 elements, 15 columns. So all the states intersecting with my polygon actually being selected. So in here, and if you have a large collection, usually you don't want to print out because you are getting all the data trying to do here. Kind of like you are watching a movie and you want to download the movie all of a sudden to your computer, entire movie. Because when you are requesting this data, you need to go attribute, all the attributes. So it's going to take some time to grab the data. And usually you don't want it. But after you do the selection, you can add the data back to the map. So assume, okay, I already have the southeastern United States. Then I want to add that. So you can just map dot add layer. Why it's so slow? And square brackets again. If you don't know like how to visualize that, that's fine. So I'm gonna southeast, and then square brackets, and run it. See? So now you see the dark color it has been added. So let me come back to here. I can turn up the US stage layer. So this is how you can filter image collection by attribute using interactive selection. So I can draw a geometry and then use the geometry to filter. Kind of like ArcGIS is doing like spatial operation. See whether two polygons intersect or not. If they intersect, you select them. Then you can save the result. No, you can do multiple. No, you can do that. So let me show you here. Good question. So I can open this one again and then turn this one off. So for example, they say, okay, my study area is the coastal area, right? So you can, for example, do this and run this. West Coast. Can do another one. Can do it carefully, but I just want to select somewhere like this. Okay. So and then escape. So now I have these two lines, right? So if you need the two lines, is use the map.user ROIS. It's a feature collection. If the ROI user ROI is only the last thing you draw, because you draw multiple times. So if the user ROI is just this one, user ROIS will be this one, and then the source code is the same. You don't need to do anything else. Okay. So I'm gonna run this. Right now, of course you can change the name. Oh, ROI. Sorry. Right. The reason that ROI is just the last one. If I run this one again, or lowercase, is run it. See? So now I selected all the states that are postal states. Take a look at this. See that? So this is kind of how you select that. You need to figure out what you want, and then you tell the computer to do that for you. Then I can remove these feature collections. Now I have all these states. Then you can use this to do, for example, filter the images, filter other stuff. So basically, you have a chain of operations. So this is how you select interactivity, and this is good. But again, when you are developing scripts, you want to minimize interactive operation, because if you send the notebook to someone else, for example, you are doing grading, okay, you do the assignment and then you just do the interactive selection. I don't know how it's selected. I don't know what you do with the map. So usually it would be better to just code everything in the source code. So when people run your source code, you get the same results. So in that way, you don't need to ask them to do selection. So here, for example, I want to specifically select, for example, which one? Florida and Texas. Okay, I want to select these two states. I want you to don't use the interactive selection. So can we do that? So here, if you want to something specific, you need to e.filter. Okay, and within there, so Earth Engine, everything is just basically object oriented. So within there, you need to pass in a filter, and you can go to the Earth Engine documentation, seeing what filter is available. So go to the reference, and then client libraries, and scroll down. There's e.filter. Okay, so this is where you actually figure out what kind of filter you use. How many of you use ArcGIS? Have you ever do a selection attribute table? select like, okay, the state, the column name equal to Texas or equal to Louisiana, whatever, right? So here is the same thing, but you need to construct a filter. So the construct filter here will be either filter and then EQ. EQ means equal. So if you're trying to find something, okay, the state name equal to something, you want to use this one. So you want to construct this e.filter.eq, name of the column and also the value, right? So if we come back to here, let's say I want to select the state of Texas. Then you'll be e.filter. Basically, you are constructing this one. Just like this is the, when you do ArcGIS, you do the selection. And then you select, double click the column name and then choose the value. So it can be EQ, okay? And then EQ, you need to have the column name and also the value, right? And that is what I asked you earlier. Sometimes if you don't know what attribute table it has, it's easier just to use the inspector to see what is that, and then you pass into your source code. So for example, right now I want to select Texas. Okay, I just click here, and then I inspect what attribute of this feature collection, right? So how do you indicate it is Texas? Either by name or by ST-USPS. So for example, okay, we can just use the name. Then you'll be here, single quote or double quote, name, and then comma, and then quotes again. So you'll be Texas. Okay, something like that. And then if I run again, that you'll be just Texas. Hopefully. Don't know why it's so slow today. And this is just one, but if you want to select multiple states, then just look at this filter in here. If you do multiple selection, I would recommend using the ones called in list. In list means either filter, in list, and then the name of the column, and then you can pass in a list of multiple columns. So I will show you an example here. Okay, now you see Texas. Right. E to EQ, and then the name of the column. So if you want to select multiple, it will be something like this. Okay. Again, you just hit tab period, and then hit tab. Then you can see what's available for that filter. So in list, okay, parentheses. So the first one will be the same. It will be the name of the column. So name, and then comma. Okay, and then the next one will be, oh, it's a list. So that's like Python list, a square bracket. Okay, and whatever state you want to select it. So in here, just Texas, and then, for example, next one, Florida. Make sense? So right now we are selecting state name equal to either Texas or Florida. And let's see if it works. See? Can you add more? Right? I can add another one. Be Tennessee. Okay, it's faster now. So you can select any way, like you can select all of them. How about I ask you, please select all the US states name start with the character C. How many US states starts with the character C? No? Connecticut? California? Colorado? It might be more than you think, right? So, but if you know how to use it, it's actually pretty easy. Let me show you how you do that. So either filter, and then probably this one to start with or something, right? Or end with. For example, what kind of US states ends with A, Apple, right? It's probably that one is more difficult, but start with this, do with this one. Why either or? No, I think it's not this one. Yeah, string start with. Okay. I think it changed the name. I don't remember it's this one. Okay. So I'm going here and then shift tab. Okay. And then the will be the column, right? So that basically means the first column will be at the name of the column will be name, and then comma C, uppercase. All right, and let's see if it works. Yeah, have an extra one. Right? How many? That's 3. So you can actually do it. So here I can do se dot size. Okay, 4 actually. So it's more than where's so California, Colorado, Connecticut. Why there's 4? There might be a tiny one somewhere. So if you want to see it, I can just type out the name of the variable, and then you should be able to see. But usually you should avoid using this one because especially you have a vector data, it's pretty big, it's going to be slow. So let's take a look at what is it. First one, Commonwealth of Mario Island. Commonwealth. You can never guess. Like I have no idea. So this is like the territory outside the continental U.S. But next one here, Connecticut, and then what else? Colorado. Yeah, so 3. We are pretty close, right? So this is how you can filter. For example, you can either by list, by interactive selection, or you can by do this, and then what else? How about how many U.S. states the name ends with A as Apple? Right? Can you guess? You'll be ends. Okay. Give me an answer. See who can get the most close to the answer. 15. Okay. 8. Okay. Any more guesses? Name. It is upper or uppercase. Okay. And then comma. Okay. Lowercase a. So let's find out the answer. 8, 15. Oh. 23. Not even close. It probably it's hard to tell. Yeah, it's real, right? Montana, Dakota, number. Yeah, I like more than 1/3 of those actually. Can we say? Again, those are also very simple to construct. So we can do here. You can either filter, or you can even by population. So we see here, for example, I want to select the U.S. states that the area greater than something. That's also feasible. So what you can do here is to find out which what's the name of that area. So we're gonna figure out here, click and take a look. A land, a water. So basically, area of land, area of water. Is there just an area? No. So for example, I want you to find out the state area greater than a certain threshold. I don't know about this number. It's just way too big. But you can just, specify whatever area you want. So in this case, we need to use this name, and also here, I'll show you. So it'll be right now we need to change to a lane, okay? But here we don't use a string. So if you want to try to find out the area greater than something, it will be GT, okay? So if less than, it will be LT. This will be lowercase GT here, or GTE, greater and equal than something. So if you're working on population, for example, you are interested in selecting US states that with a population greater than something, then you can do this way. So here I'm going to do the area, and then you can just specify number. So this is not a string. I can say, for example, 10 to the power of 9, for example. Probably that's going to be a lot. So this would be 1 million square meters of all the states. Might be all of them. I'm not quite sure. This, see? Oh yeah, it's indeed all of them. So the number is way too small. So because it's square meter, so probably I'm going to change to square kilometer. So let me change to maybe 12 and see how many. Oh, nothing? Okay, I'm sorry. It's too big. So maybe 9. Hey, did I do 9? Oh, it's either all or none. So maybe 10. Can keep trying. You see, now it start giving some of the states that are smaller. So if I do 11, then probably it will be none. Yeah, it's none. It's way too much. So probably I can maybe half multiply by 10. I don't know what exact number is this. Density. Okay. Who's that? Texas, right? Probably Alaska is also selected here. Right? So those are the two states that has area greater than this one. Understand? So now you can do all kind of filtering. So make sure that you understand the filter. You can filter bounds, you can filter dates, you can filter by geometry, something like that. And lastly, I want to show you is like when you, for example, when you do the imagery. So let's go back to the example here. We do the what's it? The Sentinel-2, for example, right? And let me run this one. So assume that you have created Sentinel-2 images for a specific location, and now you want to clip the area. There are two ways you can do that. You can clip by geometry, or you can clip um, or you can clip by a feature collection. So there are two ways you can do that. So let me show you quickly how you can do the clipping. So assume this is the global scale Sentinel-2 imagery, right? Now I just want this area, so I can do this. Simply draw a rectangle, right? And then I can get this variable. So this is the image in here. I can just come to here, add another line, and then it will be, for example, subset equal to image. Oops. Dot clip. If you type C at IP, so there are two ways you can clip. You can clip by a geometry or by a feature collection. Geometry usually means just one single geometry. So this would be m dot user, okay, RI, right? And then I have this clip. Then I can map dot add layer subset, okay. And then you can comma like this. You can deal with the visualization later, but for now, it might take some time to load up. But right now it's like all black. But I think there's some oh yeah, it's right. Yeah. So you can maybe just use the visualization here. So this is how you clip the be better. So it might take some time. So this is how we do the interactive selection. But you can also do filter collection. Okay, look at this. So now you search all the images and then you return just a subset of the imagery. So this is one way. The other way is to use feature collection. So you'll be here clip to feature to collection. And earlier we used, for example, select state greater a number that greater than a certain population, right? I think the variable is AC, and then you can do this, but you need to basically go to the US. It might take some time to load up. But basically, you can clip the imagery by image, or you can buy feature collection. So if we come back to the US, it might take some time to load up. But in Texas later, it will come. The image will be loading up. You see, it's still loading up. But this is the way that you can clip image collection. Okay, we are running out of time. So the rest, you can start doing the lab assignment. Log into Canvas, and then just pull up the notebook, and then you can start doing the quiz.